What if I told you that a single missed check could take down Google Cloud, disrupt millions of businesses, and cost hundreds of millions of dollars, all in under 1 minute? That's exactly what happened in June 2025 when a simple bug at Google led to a global outage of Google's cloud, workspaces, and security services. Today, I'm going to show you step by step how this happened, how you can reproduce it yourself, and how to protect your own systems so you never end up as the next big tech disaster. If you care about real world DevOps, cloud reliability, and practical lessons, hit that like button, subscribe, and let's dig in. On June 12, 2025, companies and users all over the world started seeing 503 errors from Google Cloud and even Google's own products. Their mission-critical API gateway called Service Control was crashing in every region, causing major outages. But what actually triggered this disaster? It came down to three things. Number one, a risky new feature to improve quota checks was shipped without a feature flag, meaning it was live everywhere, not just in a test region. Number two, a classic programming mistake, a missing null check was lurking in the new code path. Number three, when a policy change with a blank field was rolled out, it triggered that buggy path everywhere at once, instantly bringing down the entire control plane around the globe. Now let's recreate this exact failure in code so you can see just how easy it is to make and just how fast things can spiral out of control.
Here's a simplified Java version of what went wrong. Let's walk through it together. I created a policy config class to represent a policy, just like Google's internal system. If we scroll up above, there's a main function. In this, we have regions: US Central, Europe West, Asia East, standing in for Google's global footprint. We simulate a bad policy update with a blank name. This is our ticking time bomb, just waiting to go off. Now check out the deploy policy broken method. Notice there is no null check at all. We just call uppercase on config.name. If config.name is null, Java instantly throws a null pointer exception. Let's run this code and see what happens. First, I'm going to compile this code using javac compiler command, followed by I'm going to run this controller.demo. See those repeated null pointer exceptions? Each region tries to deploy the bad policy, crashes, and then retries only to crash again and again. This is exactly what happened at Google, except on a much bigger scale. Every region tried to recover, but without any error handling or backoff. The systems just hammered themselves over and over, making recovery even harder and prolonging the outage. So a tiny missed check became a global event, and it all started with just a single bad input. But how did this bug take down the entire cloud so quickly? Because Google's cloud service control policies are replicated globally within seconds. That's usually great for performance, but if you push a buggy policy like our blank field here, every single region gets hit instantly. No feature flag meant there was no safe way to test or roll back the change. So the whole world felt the impact at once. Now let's fix it. I'm going to add another method saying deploy policy fixed. In this, config.name is equal to null. In the previous method, we did not have anything like that. And the system will print this particular error. Policy name is missing. deployment aborted. Okay. Next, add a feature flag at the top of the main function so you can control risky code like Google should have done. Update this with false. Okay. With the feature flag off, the service uses only the well-tested safe code path. Let's recompile and run it. Java C space service control dot Java followed by Java service control demo. This time you will see error messages if the policy name is missing but no crashes. You see, the system gracefully logs the errors and keeps running. This is what Google is now requiring for all their critical systems. Guard every risk, change with a feature flag, and always check for nulls. But what about recovery? In Google's outage, every region tried to restart immediately, hammering their own infrastructure and making things even worse. Let's update our retry logic to use exponential backoff, a best practice in cloud engineering. In your retry loop, make each retry wait longer like this. Now, when you run the code, retries slow down, giving the system a chance to recover instead of making things worse. These small changes, null checks, feature flags, and backoff, are what separate resilient systems from the one that crash hard. So, what did we learn from this real world disaster? Never deploy risky changes without a feature flag. Always test new code in isolation first. Never skip basic error handling. One null check could have saved millions of dollars. Test every code path, even those you think are impossible to hit. Design for failure. Use backoff and isolation so one bug can't take down everything. And the very important point, my favorite, communicate early and often, internally and to your customers. If this can happen to Google, it can happen to anyone. But if you build with these lessons, you'll make your system stronger, your customers happier, and your job a lot less stressful. If you found this breakdown helpful or you learned something new, smash that like button, share this with your team or anyone who's ever written a null check, and drop your outage stories in the comments. And if you want more hands on DevOps, cloud engineering, and postmortem breakdowns just like this, make sure to subscribe and hit the bell icon. I'm Arbaz. Thanks for watching, and I'll see you in the next video where we make sure your cloud never goes down for a single missing check.